Hello, my name is Igor and welcome to my Tech Farm. And this is another Ender3 V2 upgrade video, and this time I'm installing the full metal hotend kit, and this box is sent to me by Micro Swiss for the review. But first let's see the reason for this upgrade. For this we must understand how the hotend works. So let's start with the heater blocks, and inside this is the cartridge and the termistor. And this is the place where the filament is melted, and through this nozzle it goes outside from the hotend. Now above the heater block is the heat break with the small cross-section area, and with this smaller area less heat goes up into heat sink, where we have some cooling fan, because in heat sink the temperature is so low that here the filament is still solid. The structure of this hotend on Ender3 is that this Bowden tube or Teflon tube goes inside completely down to the heater block. So this means that this is the weakest point of this structure, because in the heater block, if we want to have, I don't know, 250 or 60 temperature, actually that temperature will touch this Teflon tube. Even on Creality website I couldn't find the maximal temperature, recommended temperature. Of course, with the settings we can set up to 260 degrees Celsius, but with this Teflon tube most of the experts don't recommend to go over 240 degrees Celsius. I was printing some ASA on 250 degrees Celsius. I didn't feel too comfortable with it, but I do it very rarely and only maybe up to maximum 1 hour of printing. So if I want to constantly use those maximum 260 degrees Celsius, then definitely I will need something like this. So this is the all metal hotend by Micro Swiss, and in this case end of the Teflon tube is in a heat sink. So this means it's not limited by this temperature down. Theoretically, if we upgrade the firmware, we could go even above 260 degrees Celsius probably. I'm not sure, it depends on the cartridge and the termistor, what is their maximum temperature. But with this hotend, we are not limited theoretically to this 260 degrees Celsius, but at least we can use constantly that temperature without any problem. Another reason for this upgrade for me is that hardened steel nozzle, and thanks to that nozzle I can print abrasive materials like glow-in-the-dark filament or maybe carbon fiber material and similar. Now before I continue, according to information we have to reduce the retractions and similar, so don't expect better quality with PLA and PETG. So this upgrade is useful if we want to use those higher temperatures constantly on your 3D printer. Okay, the assembly is very simple, mechanical part, and you can find very nice video on Micro Swiss website too, but I will do of course my assembly tutorial. I will show you at least my suffering if we have some problems here. So let's see what's in the box first, and then let's start with the assembling. Heatsink with the heat break. This is the heat block, some screws, some tools, and this is the steel hardened nozzle and silicone cover. Here I take them out from the bag. Be careful because there are some very small parts like this set screw. First step is to move the Z-axis to some height where it will be comfortable for the work. Okay, let's remove first the silicone cover. And now let's preheat the nozzle. Let's remove the nozzle. So it's preheated now, and I'm using 7mm wrench. And it's too big for this. For this nozzle I need 6mm. Now be careful, the nozzle is preheated because we need it so any plastic inside will be melted. It's much better if you have this kind of the wrench, If you have only some kind of open-end wrench, in that case be careful, because it's hot, it will fall down when you unscrew it. So this is my method. I will unscrew only maybe 2 rotations. You can leave it like it, cool it down, and then when it's safe, just in case, use gloves, and then you can turn it on. So now I will cool down the nozzle. Now it's almost cooled down, so I can unscrew it with my hand, just in case I will use gloves, but be careful, make sure that it is really cooled down. And you can use some ceramic plate or something like that for this. Here it is. Now we can turn off the machine. And we don't have that fan noise anymore. To remove the fan cover, unscrew this bolt here. And then gently we can turn this fan cover, but be very careful because there are some wires attached to the fans. Next step, I want to take out the Bowden tube, but I have to take out this clip here. But first I need to turn it in my case. Okay. And now I press down this lock mechanism, and then I can pull out the Bowden tube. Actually, the end of this tube is looking quite good so far. So a few times printing on those 250 degrees Celsius didn't damage it. And if it doesn't come out easily, try to again preheat the hot end, but be very careful because this will be very hot. The next step is to remove the original hot end with these 2 bolts. Next step is to remove the heating cartridge and the termistor from this heating block, and they will be inserted into a new heat block. They are held with these 2 screws, so I have to unscrew this screw here. It's not tight and it shouldn't be tight, it only holds the termistor wires in place. Okay, I lost that one. And with this set screw, it is secured the cartridge, so I have to unscrew this one to take out the cartridge. Okay, and now carefully I have to take them out. I can see that, okay, they are coming out very easily, so I thought it would be a little bit harder. The cartridge I could push from the other side, but it came out easily. Reinstall the heater cartridge and the termistor into new heat block. There is a small hole for the termistor. And then secure them with the screw. So don't hold the wires when you are tightening these bolts. I'm holding from these 2 sides the heating block. So don't forget, only secure it, but don't tie too much. You don't want to damage the wires. Take out this heat brake. In my case it was screwing into this heatsink, and screw it into heat block. These are bolts from the opposite side of the head of these bolts. And tight it slightly with this open-end wrench. I think it's 7 mm. Install the new nozzle from the other side. And tight it with the same open-end wrench. Again, be careful, don't hold the wires, only these two sides of the block. Don't worry about this gap, because the nozzle have to lie down to this heat break tube, not this surface on the heater block. Install the cooling block back to this plate. Of course, here is the place for the hotend tube, and here you can see the cones for the countersunk bolts. So it has to go in this position. Insert this small set screw into cooling block, and only turn maybe one turn to leave it in place, but we don't want it on the other side yet. And now let's insert this heat break into cooling block, and we have to press it completely up and then secure it with this set screw. Okay, I can feel it's completely up, and now I am tightening this set screw to secure it in position. Now it's time to insert the hotend tube into the cooler block. Mine is in quite good shape, but probably if yours is in worse shape, it is good to cut it now. But it is very important to cut it perpendicularly. Download it from Thingiverse, very small, compact. And now push down the hotend tube, approximately, I don't know, 6-7 millimeters deep, and secure it with this plastic clip. Again, check that it is completely to the bottom of that step hole. Okay. Now let's turn on the printer. And heat the nozzle to the 230 degrees Celsius. The nozzle is heated up, and it is a very critical moment. So I'm using this open-end wrench provided in this box, and I'm using a 7mm wrench from the other side to tie the nozzle to this heat break tube. This is important because the nozzle, as I mentioned earlier, has to lie to the heat break tube, and be careful because now it is heated up. So this small wrench already, I can feel it is at least 60-70 degrees Celsius. It's still heated nozzle. It's a good opportunity to check the securing screws for heating cartridge, and also this small securing set screw. Make sure that it is cooled down. Now I can place the silicone cover. So first pop it from the back side. And then the front. This is how it looks like. And I can mount the fans back. This part goes here on the side, and this one here, you have to be pop into this hole, and then secure it from the other side with the screw. Now I have to level the bed, and I will do some test print, first with some PLA and then with ASA on 260 degrees Celsius. Now this tutorial is not about leveling the bed, but very quickly I will explain. So before I start with the homing, first I will lower the bed surface at least 2 rotations maybe with these knobs, because I want to make sure that this nozzle is not bigger than previous one. It will not hit the printing surface. So like 1, 2, 1, 2, 1, 2. So with this I'm lowering the bed, and now homing. Okay, it stopped approximately 3 millimeters above the printing surface, so it's a safe method. I prepared some small test prints, but I have to modify. I cannot use the old G codes because in this case I follow the instructions from the Micro Swiss, and I want to reduce the retraction. They said maximum 4 millimeters, but I will start with maybe 1 or 2 millimeters, and then I will raise the retraction until I don't have a problem. This object is for PLA stringing test, and I'm changing the temperature and the retraction. And this bolt will be printed with ASA, and I'm changing the temperature, the retraction, and I'm adding the brim. My first test print will be with this Game Bear, the PLA. Printing is almost finished. There is some little stringing at the end on top of the printing. I hope it's visible on camera. So probably I will raise the retraction to maybe 2.5 millimeters or maybe even 3 millimeters. So this is something I have to experiment more. Not bad for 1.5 millimeter retraction. But I will remove the PLA now because I want to test this ASA, and I hope it's visible on screen. 260 degrees plus minus 10 degrees Celsius. But unfortunately it will not be visible so good because I have to move the printer inside this enclosure. This is ASA now. (260) and 105 degrees Celsius will be the bed temperature. One of the disadvantages of this enclosure is that we cannot see so good what is inside. And it's finished. Printed on 260 degrees Celsius. It's still good to the printing bed. I have to wait to cool down this surface and then I can easily take it off. Before I take it off, I'm just curious, does it work already? Great. I know horizontally printed board is much stronger, but I need this for some experiments, so that's why I printed in vertical position. Bed temperature is 70 degrees Celsius, and I noticed that it's coming down very easily. And printing is fantastic. Great. Now with this upgrade I'm able to print on 260 degrees Celsius even for longer prints, and thanks to that hardened nozzle I can print now different abrasive filaments too. But my question is, should I stop here? because this hotend is able to print on even higher temperatures, but we are limited now with 260 degrees Celsius by the firmware of this Ender3 V2. I'm not sure about the heating cartridge and the termistor, can they handle higher temperatures, but it would be good to somehow modify the firmware at least, I don't know, 10 degrees higher. Theoretically, the firmware upgrade on Ender3 V2 is very easy because it has its bootloader. So all I have to do, go to the Creality website, download that bin file and copy it to the SD card and insert the SD card into printer, and when I turn it on, then it will be automatically uploaded the firmware. It would be good if we would have that bin file for, I don't know, Micro Swiss hotend or at a little bit higher temperatures, and then we don't have to do any modification. But since we don't have, I have to download the source code and to modify that and compile it to create that bin file. Now, before we start, it is important to find out the version of your motherboard. There is no other way, but you have to open the cover on the bottom. You can see in my previous video, there I detail explained how I will open that cover. And in my case, it is version 4.2.2. Maybe the newer ones are 4.2.7. It is important in one of the next steps. Well, first step is to go to the GitHub Marlin page and then download the zip file. And we will need another file, it's in config, and it's this one, different configurations. So we have these two zip files and we have to extract them to one folder we choose. I will just unzip this folder. And then here there is another folder, so-called Marlin. And here I have to copy, this is the second file. I will not extract the whole file. Only I'm searching in config examples, the Creality, Ender3 V2. So I will copy these files and overwrite files if they exist already, like this configuration. Next step is to download and install the Microsoft Visual Studio Code. It's a free software. And then first step is to click here on extensions, and we have to add two extensions. I already added those, so they are here, but if you recently installed it, search for Marlin and auto build Marlin, and you will have here the install button, so install that. And also platform IO. So this one here, as you can see, it's already installed, so but you will have here the install button. And now we can start a new project. So now let's find that Marlin folder, open folder. So this is the folder where I download these files. And now we can start editing the files. So in platform ini we have to find this line here, and we have to replace this text with something else. Marlin pins with this line here, with this string, and it is case sensitive, so I'm just copy pasting. Okay, now configuration file, and it's already prepared for this Ender3 V2, but we have to do some small changes. It's in configuration.age. Now here are the temperatures, and I will change this 260 plus 15, so that's 275. I will change this to 285. Now this line is important here in configuration.age. If the version of your motherboard is 4.2.2, then this is what it has to be in this line here. If it is 4.2.7, then you have to add here V427. And those are all the modifications I did now, and let's compile the file. So here I have to click on this button, and after some time it should say that everything is okay or success. And after approximately maybe a minute or two, you will have this line, success in 1 minute and 8 seconds. Press OK to close this terminal. Okay, and now let's find our file. It should be in here it is. So I have to copy this bin file to the SD card and insert it into the printer, and when I power on the printer, the firmware theoretically should be upgraded. And then the screen, if I want to upgrade, then I'm going back, Marlin, and I have to copy this folder here, which was from the zip file. This has to be copied to the SD card and inserted into back of the LCD screen, and then it will be upgraded. Well, we will see soon. So I insert this now, the small SD card, and I will copy this bin file here, and of course it's very important to be formatted to the FAT32, and we see it work. So this is my current firmware version, and now I will turn off the printer. I will insert that SD card with the .bin file. And now I will turn on the printer and follow the changes. And that's it. Let's see any changes. New firmware version. Just curious. Can you see? 270 degrees Celsius. Now, if this would fail, don't panic. Just download the original Creality bin file and use that for update. And don't forget to take out the SD card at the end, otherwise you will have the black screen next time when you turn on the printer, because firmware can be updated only if the file name of the bin file is different from the last installed one. Now let's update the screen. I'm deleting the bin file from the SD card and copying the dwin set folder to the card. It's in a Marlin folder. We copy it from that configuration files. Of course, firstly you have to take off the screen from the holder and then unplug the cable. And I want to take off this back cover by removing these 4 bolts. And here we have a slot for the SD card. Plug the cable back. And I will turn on the printer. And when the screen turns into this orange-red, then the firmware is updated. I can now remove the SD card and place the cover back, and then see the results. Turn off the printer, unplug the cable, remove the SD card, and place back the back cover. Okay, now let's print something. I already prepared one G-code with 270 degrees Celsius. the same G-code, same bolt, but now with the 10 degrees Celsius more. The nozzle is already on 270 degrees Celsius. Now I'm waiting the heated bed to heat up to 105 and it will start printing. The same bolt, same G-code, only the temperature is different. I have to install some camera inside. Oh, this is really torture. Looks good so far, but no opening until it's finished. It's almost finished. I want to record the end of the printing. The conclusions. Well, to be honest, when I recorded that video with the firmware, I wasn't sure that I will success. I'm not sure if I did everything correctly, so I raised only by 10 degrees Celsius because I'm not sure. So I know that this whole metal hot end can handle higher temperatures, but I'm not sure that heating cartridge and termistor from the stock Ender3 V2 can it handle it. So it works, but if I did something wrong, please write me in the comment. If you want to print only PLA and PETG, then you don't need this kind of upgrade. But if you want to print anything on high temperatures, or you want to print abrasive materials, glow in the dark or carbon fiber, in that case this package will arrive with a hardened steel nozzle, which will not wear so fast. And with small modification, if you are happy with the constant 260 degrees Celsius, then it's very easy. The mechanical installation of this all-metal hot end is very simple. If you need more, then definitely you have to upgrade the firmware, and unfortunately they are not prepared firmwares, because if it's prepared you just copy it to the SD card and insert in the printer and it will be updated. I was communicating with guys from Micro Swiss, and they told me that they will prepare these bin files for most popular 3D printers. Depends whether you watch this video. If you are watching 1 year after I did it, then definitely doesn't make sense maybe to edit the firmware, because probably you will get the prepared binary file on the, I know, maybe Micro Swiss website or somewhere similar. Anyway, I hope you like this video and maybe you learned something new. I definitely did. And I hope you will follow me to the next video, which will be the BL touch sensor and things I learned from this editing the firmware. Probably I will use here too, but good news is that on Creality website they have prepared firmware for this BL touch. And I hope you will follow me to that video too. Until that, thank you for watching and happy printing!